Okay, thank you. Yeah, so my official title is project manager at Notions Research. So we're in the insurtech space, and we do machine learning data science for insurance, more specifically healthcare insurance. I've been doing ML products for 4 years now, more. And in this talk, Ashley's talk was very tools and process heavy. And if you go to the next slide, Ashley, please. Mine is less so. Mine is more on, that part 4. So if you are done with your ideation phase and opportunity backlog, and you have the sketching and you have identified value, you've done the initial calculations, you have the canvas, you have everybody aligned, and you go into the solution design or solution implementation, the POC phase, whatever way you structure your project. I'm going to talk about some principles and rules and give you some real use cases that I've encountered that basically help you bridge the gap between getting to that monetary evaluate support phase from the opportunity sketching. So yeah, that's essentially how to accelerate the value delivery. And the talk is titled Structuring Machine Learning Projects, and there's a lot of material out there already. There's a whole course with that title on Coursera by Andrew Ng. I recommend highly for everybody to check it out. But I'll talk about my personal rules and experiences that I found very effective. And I'll back it up with some examples. So if we go to the next slide, essentially the stuff that I'll talk about in the next 8 to 9 slides is basic principles that allow teams to just deliver value faster, increase the feedback loop, get to clear metrics, and how to always have this indication of progress, right? Sometimes I find that it's in the weeds in the middle of the project or product development. Your teams get stuck and there's like 1,000 ways to go, but how do you pick the right one? Some results that I've seen that from applying these with teams, 50% in reduction in delivery time. I actually have a really nice use case where we went in and the team was struggling with like an 8-month engagement, and it was a pure kind of waterfall setup, which is not good. But the same team, same exact use case, have been able to restructure the project and went through 3 iterations in 4 months. So that's part C in that same use case, where these kind of principles allow you to ship 3 times faster. Another use case, there was a model delivered and project was closed 2 months ahead of plan. It was a POC. So it was a 40% reduction. The team was really surprised that they finished so early, and the client as well. And from part D, from the word velocity, you can see that very Scrum heavy. So these principles and rules have allowed an increase of up to 3 times and more. So if you go to the next slide, Ashley, I'll talk about the overall, why the projects are tricky, right? Because they're highly iterative in their nature. One of the greatest things I hear from data scientists and ML engineers is that, or researchers, that all the software development stuff, the Scrum and Agile or Waterfall, it doesn't apply to machine learning because it's sort of like a tree search. You have to go down one path, figure out what's going on. Now, again, this is different for experimentation phase. Also depends on where you are in the phase of the project. But essentially, you're always doing this, right? You define a task, you do a collection of data, you test and evaluate. Sometimes you have to go back. It's not a straight through line of progress, right? So the next phase will have even more iterations. Sometimes the next phase is the previous phase. And even after you ship, you just can't relax. You have to always monitor and maintain the models in deployment because the data distribution might change and inputs, and you always have to iterate. And there's a really cool, very extensive guide in the source that I put there. Please check it out, with a lot of checklists on how to structure your projects better. But you always have to remember that when you go into these ML projects that you will always be iterating and you'll always be going back sometimes. So next slide, please. Another thing that I find why I put this here, even though it's basic, you always want to think in shippable increments and deliverables. It's very easy to fall into this trap on the left, and don't do this. Try to avoid it as much as possible. Of like, okay, we're gonna identify the use case, gonna get some data, last mile ETL, do some feature engineering. Just basically go away for months and then come back with the result. Try to do that, but faster. Find a way to slice the problem so that you're thinking, okay, how can I get to a result that I can learn from efficiently? And then iterate on that. So try to think in terms of on the right, but not on the left. I know it's very basic probably for everybody in this audience, but I find this all the time with teams, starting from the beginning of the project, and sometimes even in the middle when you're doing iteration. There's always this urge to do some more analysis, to do something more. Try to like move away from that kind of mode of thinking. So next slide, please, actually. So rules, there's a really good paper by Martin Zinkiewicz, the rules of machine learning at Google. So I was really inspired by that, but I'll give you only 5 rules. He has like 40 or something. So you really want to be lean and agile in everything in terms of, first of all, you need to understand your constraints, your context, and your environment. So the canvas helps you map that out. Just remember that one recipe doesn't work always. And you have to be aware. Is this for an external client, or is this an internal project? Are you part of a bigger company? Then this is for internal users. What is the most important constraint, right? Is it time? Is it money, or is it the quality? You always have to remember those basics, and then based on that, just plan just enough work to deliver value fast or get to a place where you can learn. The second point is just be flexible. Always try to deliver value and just remove waste. It means like use the most efficient frameworks. So if it's Scrum, then use Scrum. If it's Kanban, then use Kanban. Don't be stuck. Adopt practices that improve processes and drop ones that just don't help. Personally, we've ran Scrum for certain phases, and we've ran Kanban for other phases. We've changed, tech leads and team compositions based on the needs of the phase or the project, and we've always tried to just deliver, and always prioritize and strive for clarity. And because it doesn't matter if it's something insignificant, like if you're fixing an error that is going to give you 5%, whereas you could be fixing an error that can give you a 20% improvement, then probably you're not working on the right thing. And just strive for clarity. Get everybody on the same page, align, do the showcases, do the reviews, do the the retros, and make sure everybody's on the same page on the team. So we'll go to the next rule. So rule number 2 is use validated learning, right? Always start. So this is lean startup. I think nothing new, but again, always start with a definition of done for everything. You need to have a definition of done for your project, for your product, for your iteration, for your phase, for your sprint, for your tasks. And the most important part where this works is actually if you have this innovation metric, right? Where you have a metric that is very, very important to the user, and you somehow map that metric back to your technical metrics if possible. And then you always show progress against that metric to the client. And that way, all this talk about hyperparameter tuning, debugging, different directions you can optimize or different directions you can choose, it just makes things clear. Whereas you're showing, progress against the metric, and you can see with your team that you're doing well or you're not doing well. Sometimes it's not so straightforward to find it. So like with the case that Ashley mentioned, there was a KPI of increasing, true positives by 25%. But how do you test that, right? So, we took samples of historical data, and the client, for example, took a sample of data that is from a different year. And the first milestone was to basically get overlaps, which was the baseline, essentially beat the simple system baseline, right? And when we started doing that, everything just went into place. And we used the feedback and the debugging sessions and the workshops to find new features and improve our models and improve our pipeline and improve everything else. So with that, let's go to the next slide. Rule number 3, I guess this is explanatory, but start with a simple system first and then iterate on top of that. So try to build end-to-end simple models and then check against your innovation metric. Use that as a benchmark and then iterate over until you reach the definition of done. So start on the left, don't start on the right. Why I say it's a possible direction is because if at some point you reach a definition of done with, you don't use an LSTM, but it's XGBoost, then you're done until the next engagement or until the new subscription or the renewal of the subscription or whatnot. There's sometimes in the team, there's rockstar machine learning researchers and data scientists that want to tackle everything with the shiny latest model. But the problem with that is then it's very hard to debug and very hard to understand what's going on. So try to start simple to understand the data, understand the problem space, understand what gives you the best value, and iterate over it. Yeah, so next slide. So this slide I'm going to spend a little bit more time on because this essentially shows you, I didn't take time to make it nice and all that. Sorry about that. But this is essentially from our Confluence roadmap. This is what we used to go 50%. So what we did is we figured out our cadence. We figured out how long it takes us, given the pipeline and given the constraints we are at, how long it takes us to deliver a full increment. So the early delivery red lines there is essentially every 3 weeks, we figured out every 3 weeks, we can deliver a fully end-to-end working version of a model that we can compare the previous model against. So in order to do that, there were several things that needed to happen. We agreed with the client that every 3 weeks we'll do a workshop, we'll present the latest results. And for that to happen, we had to have a small subset of data. So essentially what we did is we took 100 samples from the client. So we had training data for 3 years, and we didn't have the validation data, as in like outside validation from the client, on a different year, and we didn't see it. So we told them, okay, so the metric is overlap, right? We need to beat the current system. And then we said, okay, blind test. We're going to give you the model, and you're going to run it on the blind data set that we don't see. And out of 100 cases, we'll see how many overlap. So at the beginning, we were overlapping with a very complicated model. We were overlapping very low. It was like 5 out of 100 or something. Iteration 1, we are doing our analysis. We talked to the client. We figured out that there were a lot of bugs in the pipeline. There were a lot of features that were very useful that were sort of inside the heads of these investigators and in the process and in different databases that were sitting around that we didn't know about. But this like 5 out of 100 number was very clear to us and the client that we were not doing so well, allowed us to always iterate. So we showed it at iteration 1. We were up to like 15. And then we talked to them some more. We debugged the cases with them. And they told us, okay, in this case, the model is saying something correctly, probably, but we don't do this. For example, there were some cases that they just always paid out because of ethical reasons. And this is what we learned. We essentially incorporated new features continuously. And what we also did was whatever didn't make it into, for example, early delivery 1, let's say we're in the middle of analysis of a feature on how to incorporate it into the pipeline, we just said it just goes into iteration 2. Whatever didn't make it into iteration 2 goes to iteration 3. And that way, we're just able to ship out these models that were improving, and that way we had this continuous improvement, and the client saw results faster, earlier, and was able to be engaged, was able to talk to us and tell us where we're going wrong. So basically, whereas before it was, okay, they gave us 1,000 cases. It took us a while to weed through them with them, and they didn't want to do it. But this way, it allowed us to do the improvements faster and better. Essentially, this works very well also for context and for environments that are not, you need to know, basically, this is a regulated industry. So this probably wouldn't work so well if we were iterating on a deployment system, unless we had an environment that is a total copy of the production. But due to the nature of regulated, like banking and I think insurance, this cadence is probably not sustainable. But essentially what you have to do is you need to find out with their IT team how long it takes them to upgrade their systems, usually like it's on the order of months. But yeah, you need to basically sync and align on the scheduling with them. So next slide, please. And what I also wanted to say is rule number 5 is that you need to focus the right team. So in order to do full increments, like what I mentioned before, you need to have a full team ready to deliver. So essentially, usually at a minimum, it's a data engineer, ML engineer, a software engineer, maybe a data scientist as well, and a Scrum Master, PO, or PM, whatever you want to call it. And I work at a not such a big company, and we always want to do more, which means that we can't have people fully committed all the time, but try to kill the context switching if you are the product manager or owner. It just doesn't work. You have more than 2 projects per person. It really kills the productivity, and you just cannot keep going like this. And on the left, you can see that I think it's a well-known thing where if you have a person working on 5 projects, then it's only 5% of his time is spent on productive work. This is a very, very painful lesson to learn for myself personally, because I've seen, and we're still trying to learn this lesson, because we always want to maximize our efficiency and we always want to go for many opportunities, but just can't work like that. So next slide. I think, yeah, I picked the most important rules just off the top of my head that I thought allowed us to do this, and I've seen. There's obviously a lot more. As I said, there could be 40, 50, 60 rules if you want. But essentially what me and Ashley wanted to cover here is that if you think about lean data science and you think about lean, what are some sources of waste in AI projects that you should look out for is, in a framework of defects, models that don't deliver, right? From my example there, the team has spent maybe 2 to 3 months working on a very complicated deep learning model that at the end of the day didn't do so well, and it was very hard to debug later. So you want to put in the checkpoints and avoid defects, and poor data quality is a defect, which leads to poor features. Overproduction, unnecessarily complicated models is definitely overproduction problem. Waiting, right? So you have big data sets and training time and waiting for data, waiting for these handoffs between software engineering or data engineers. You want to minimize the handoffs and waiting time between different actors in the process. Unused talent, so wrong allocation of roles and responsibilities is also another evil that you should probably try to avoid, in terms of you don't want to have a rock star ML researcher just doing the models himself and everybody else is just picking up the scraps and pieces. Try to maximize the use and try to bring people to the next level. So maybe you have a junior DS person who's doing data cleaning. He could try a simple model as well. Why not, right? And then learn from that. But essentially just try to maximize everybody's talents. So transportation, that one is added by Ashley. So that the costs of moving data and models in between different warehouses and inventories and whatnot is also a type of waste. Models abandoned in terms of inventory is a big waste I've seen, where you are working on something and then it turns out that wrong assumptions, or you're just going in the wrong direction. But this is a very tricky one because I guess, as I said, it's a very iterative nature of projects. So sometimes you need to go down the wrong path. So be wary of this. Unused data, yes, I think collecting data a lot and then not using it might be kind of an inventory that's piling up. But again, it might be useful 2 years down the line. So again, take this with a grain of salt. And extra processing, right? So you might want to improve your accuracy. And if you don't do the correct calculations, you might need going like 2% improvement, which doesn't really give you anything. So you want to hit that sweet spot between the definition of done and the complexity, essentially. So I think with that, Ashley, unless you want to add stuff, thank you. I tried to be a little shorter and yeah, ready for questions as well.
Yes, we're waiting for questions in the chat. I have a questions for you right now. You've mentioned time boxing iterations, and in Scrum, time box means you kind of start the beginning of iteration or sprint and get it done in the end of iteration. And usually the duration of this iteration is about kind of 2 weeks, something. But in data science, usually we cannot deliver something in 2 weeks, I mean, increment. I mean, starting the end, at the beginning of iteration, because all the data problems, you know, and
Yes.
it means that you might have several iterations to increment, or not using Scrum, or just redefine the kind of increment. What do you do? What's your kind of way of solving it?
Very good question. So I think 2 weeks is very much widely accepted, but the guide is 1 to 4 weeks, right? So if you can deliver in 1 week, great. If you can deliver in 4, yeah. Of course, you know, the different plannings, but essentially that slide I had was number 1 is you need to figure out your cadence. So if you want to do Scrum, of course you don't know your cadence in the beginning of the project, but after setting up the simple models, maybe even setting up the end-to-end pipeline and the ETL, and figuring out basically how do you figure out the time period to figure out your cadence, which is what we did essentially. We figured out after a couple of months on the project that our cadence is 3 weeks. We had this is why step 1 is figure out the speed, and then once you have that, you start just iterating. And yeah, if I answered the question there, I think.
And actually, if you have 3 weeks iteration, basically at the beginning you mostly work with data. It's more like data engineering type of work, probably, or might be. And closer to the end, iteration is more like ML ops type of work. So you might have this kind of problem. Some people are kind of overloaded at the beginning and have not enough work at the end. So you have to balance it somehow. What would you do there to fix that? Or probably you might not have this kind of problems.
Oh, so the case that I said was very specific, I guess, in terms of, we weren't doing so well, and there were just a lot of features to analyze and incorporate, and we were learning, right? So then what time boxing and saying, okay, the iteration is 3 weeks, but essentially it's 1 week for doing data analysis and getting features into the data set, the master data set that we worked on. Then it's essentially another week to configure everything and make sure everything is working correctly in the ETL. And then the third week is basically on training and testing, retraining, testing the new model. And then you basically, at the end of that, you have something to show the client. And then in parallel, you're getting this feedback from the client, but you don't stop. You go directly to the next iteration, and you keep analyzing it and putting in features and essentially improving the model. By the time the client has given you feedback and you have realized how to use that feedback to become features, you just keep adding on.
But it might ruin your iteration, right? It's just in the middle of it. You just get some feedback. You understand you cannot kind of continue to work on the same thing because everything's get broken. These questions I'm asking because we come across with these problems all the time. Like every second time we're using Scrum, because either you use raw or kind of big iteration, like huge one, right? Like maybe more than 3 weeks. Or you kind of abandon Scrum and just use it as a kind of, just every other 2 weeks we do some kind of a planning. We know we cannot deliver something, or we are not have to deliver something at the end of the sprint. We just have it like a time mark, that's all. And this kind of problems we might come across. Feedbacks, then in Scrum you have feedback, you have to get some feedback from your customer, but at the end of iteration might be too late, or can you just show some figures and they say, okay, that's figures, I understand figures, thank you very much. This is just kind of end of your sprint review.
So I guess two things here that I picked up on. Yes, like if your situation allows for effective Scrum, use it. If not, use something else. But yes, exactly. In the middle of a sprint, if something happens, right, that your sprint goal is obsolete, then you have to go back and start the sprint again. And this is actually another important point, that your client has to be comfortable with agile delivery, right? Where they have to be comfortable with seeing results that much faster, knowing that essentially they cannot expect perfect, great everything 100% all the time, right? So you really have to educate the clients. But I feel like the when you are forced to showcase, when you have to deliver something, and just gives you that kind of extra step into being able to deliver faster. And the idea is to basically, you need to close the gap in understanding. There's a lot of clients don't understand, like you said, data science, machine learning that much. Usually you're dealing with probably IT teams, probably some business users who are not sophisticated, and they don't care about your AROC or F1 or whatnot, and uncertainty and Markov chains and whatever. But which is why this innovation metric is very important, right? You have to always be able to give them the progress against it. And so that's my point.
And next question is, what kind of problems you come across when you work with business? What is the most important problem for you? Because usually people say this is like a #1 problem. I mean, other things we can kind of fix because we're smart people, right? Working with people is harder than working with technology.
Yes. So there basics matter again in the beginning. So the core theme is alignment and constant communication and managing expectations. So in the beginning, you really, really want to nail your KPIs and ROIs and get that metric, really understand the problem. If you have to, in the beginning, show them some extreme cases, right? Take something like a Wizard of Oz or an MVP approach, and you show them some extreme cases, make them understand the different trade-offs that they have to make. And it also will help you, a lot of times what I just heard, and right now I'm dealing with this actually, clients always ask, why do you need my data? Why you need so much stuff, right? Like 2 weeks ago we met in pre-sales, for example. 2 weeks ago we met, you said you need this, but now you're telling me you need more. So it's okay. Just educate that, hey guys, like 2 weeks ago you told us this, but we dig some numbers up, we dig some data around it. We need more stuff to be able to deliver something better for you, right? Like you have to show them that. And the most important, I think, confusion that comes in dealing with people is closing the knowledge gap. They are not at the same level. They have different problems. The empathy has to be there. Like you have to understand the context in which your users operate. And essentially, you want to get to the end user as fast as possible. So you really ideally don't want to deal with a department manager or the IT person that is buying the system. You really want to get to the actual end user and understand his pain. Like in our case, it was, fraud investigators. What are they dealing with? They're dealing with thousands of cases per year. What that means is that they have to look at a claim. They have maybe less than a minute to make a decision, investigate, reject, whatever, right? This is why they go for a simple solution that can give them something fast and quick. So it's people, process, and technology, right? You have to understand their workflows. You have to understand their problems. And when you come from a place like that, where you're like, okay, my predictions will allow you to do this action faster, better, cheaper, whatever. That's how you get on the same page. This sounds like really general because it really depends on the situation. Like you just have to have those principles in mind, but every situation will be different, right? But dealing with people, the only way I can say is close the gap in your understandings by using the tools of Agile, the validated learning method feedback.
Yeah, I just want to quickly elaborate a little bit on. Yes, we were talking about this last night. The idea is you don't want to allow the gap to get big.
Yes.
And I think the real challenge here is that when you don't show the client something, whatever it is, show them something, their expectations get bigger the longer that you've been away, which therefore forces you into an incremental approach. Because otherwise you're going to have to really pare back some guys' expectations when you haven't talked to them in 6 weeks. Or it's going to be really hard to have that conversation with them when it's like, guys, we need a little bit more label data.
Yeah. Sometimes you might come across with a problem that you get like they're looking at your like model, it's just improving, getting more and more like better numbers, like metrics. But then you get more data and you just get down. So you have to explain it to business, right? It might be kind of hard.
Yeah, and I don't know how much merit, maybe this is me just having a thought moment, which is like, if there is a way to optimize the number of experiments you do per period, so optimize your inner loop. And if you figure out how to do that even faster, so if it's Scrum and you figure out that, okay, we can do 3 experiments a week or 3 experiments every 2 weeks, going faster there will find you a way to get increments to the customer faster, and it'll help you learn faster, and it'll help you understand better where you're at and where you're tracking along. The reason why optimizing for that, I think, would be also interesting is that if you start optimizing for the number of experiments per week, you start slicing more thinly. And therefore, you don't take on these massive experiments that have spurious probability of succeeding. You're always tackling these really narrow ones, which hopefully you can finish inside an increment. So you can do it in a shorter period of time. And you can also know whether, well, I guess that's really the main thing, right? Is like, if I know I have to deliver incrementally, and I know I have to show progress, well, what I should do is I should slice very finely so it doesn't take me 2 weeks to learn anything. And I think that speaks to Yerzat's first or second slide where she showed these 2 loops. So the art here will largely be on, the PM or your senior technology people to figure out how to really finely slice your experiment.
Oh, you have another question. Thank you very much for answer. I need to think it over. Yeah, probably. What my problem with that is that thinking about iteration doesn't really work. I mean, Scrum doesn't work here really well. As I always more like think about Kanban, because Scrum kind of narrows us down into delivering the end of a sprint, and if it is not possible, we just feel sorry for it. And it's just painful for everybody. Or just having like, I've seen many sprint plan when we just move everything from previous sprint to the next one, like 80% of it. So it doesn't work either. So we just feel sorry for it. And they have the retrospective, understand you cannot do anything and just blame each other. So blame customer for most of the time. they haven't provided data enough, soon enough, and so on.
This is actually something else that Yerzat and I were talking about last night too, which is that like the era of like this very linear delivery of value, where it's essentially assembly line style work, where I, connect to the database, I expose some endpoints, I then connect it to the view, I then expose it. It's a very web app version way of doing things. So I get something to see every time. Whereas what we were talking a little bit about last night was essentially, are we seeing a move to more iterative, but like cyclical thing where it's like, where Kanban is still left to right, we almost need to figure out how to loop back Kanban on itself, where the learning feeds back into the next experiment. And
yeah, well, actually Kanban has this kind of a tool. So you can just have a column called post-analysis for your hypothesis or experiment, right?
Mm-hmm.
It just when your hypothesis get into this point, you have to do some kind of a post-analysis research and understand what kind of next hypothesis you should kind of put into your backlog. So basically, it's not that complicated to figure out how to do that.
It's not that complicated, but it's still, I wonder if just making it explicit will force the mindset change, right? Because right now it still is linear, right? And it still goes all the way to the done column or the post-analysis column or, learn column. And what I've noticed in my domain is that things stay in the learn column a really long time. It's not like the learn column has like an expiry date and then it forces it to come back into the backlog again.
We've been experimenting with different approaches to that, and actually for like a couple of, I don't know, maybe a year or something, we just understood that we just need to be able to decompose your project in a number of small hypotheses and just visualize it on a Kanban. And usually we try to make them small enough, like several man days, like up to 1 week, probably just small enough, and just go through all this, stages, including data elaboration if you need one. And you might have a blocker there, and just focus on fixing blocker and just getting them and discussing them during your retrospective, and some not blaming that we are not delivering. We're just having like discussion what kind of blocks we have. We just sort them out, understand what kind of a systematic problem we have within our system. System and Kanban system, right? And fix it so it works better for us. But again, it's just see different experience, and that's why asking questions.
Yeah. It's always tricky to reconcile if we have an external client, and they always want to do fixed contracts with fixed scope and delivery dates and deadlines and whatnot. To reconcile that with Agile, right? If they don't understand, it's But hopefully, you have an understanding client at some point. You're able to show the value you can bring through the engagement, and then they keep going with you.
We have a question in our chat from Valery. Thank you for the talk. Yeah, this is for me again. Thank you. Very provocative talk. I need to think it over. I just probably will rewatch it. Have you guys ever heard about data-driven Scrum?
Of it?
No, I haven't.
So I hadn't heard of it either, but it sounds like it's worth looking into. I apologize, guys. I have to jump off. But
yes, thank you very much.
Thank you very much for having me, and thank you for having us.
Thank you.
Thank you. See you guys probably next time. Maybe if you Yerzat have a few moments to.
Sure. Yeah, I can stay for another 5.
Okay.
I think. Thanks, Ashley.
Thank you very much.
Thank you very much.
Talk. Yes, I just googled data-driven Scrum. That's wonderful.
Was there a follow-up?
More stuff coming every day.
Was there a follow-up question? It was Mike, I guess.
Yeah, thank you very much, Valery, for your question, actually. So probably we'll find out more about data-driven Scrum. Maybe next time we can have somebody from data-driven Scrum just telling us how to do data-driven Scrum better way or something. Yeah. Probably the last question. We run out of time. You guys feel free to just go home, whatever you have kind of stuff to do, and probably it might be late somewhere. But just from my side, my questions I just want to ask is that we've been talking a lot about different kind of tools like ML Flow, DVC, and this kind of ways to improve your kind of delivery pipeline. Do you think them kind of universal? What's your choice? What's your favorite tools, or you just don't use them? What do you think about them?
My opinion towards tools is right time and place, and this really has more to do. Again, my topic, people heavy a lot, I guess. But it really depends on your team maturity and your company maturity, right? So I think the previous. We've been getting better, and we use DVC. So ML Flow, we're looking around at it as the open source component plus the enterprise edition has the features, but we're still evaluating. Essentially, we have very interesting use cases and very interesting requirements sometimes. So we are evaluating still, but ML Flow is something that if it works for you, then please just use it. Use ML ops tools, and they're getting more sophisticated and more complicated, and they're solving a lot of problems. So I would say, as much as possible, given your data science team competence and maturity level, use the tools for sure. Because this is, again, about reducing waste, right? A lot of waste is very simple and easy to fix.
But you kind of have to have quite long project to make it, pays off, right?
Oh,
So not always have this long project. So basically, just invest in time in this kind of things might be another waste.
Well, see, the thing is, essentially, we, maybe as in any other company, are trying to go product driven, right? So we're pivoting to a product that we want to have, and so this is more of a long-term investment for us. It's not really just projects tied to clients, but this is more about having our own infrastructure and the platform, several different layers, and being able to always churn out better models, collect more data. So this is more for our in-house development team, really. Because this is my third or fourth time seeing this pivots. Essentially, everybody starts out the same. You figure out through consulting gigs, projects, figure out the pain points in an industry or space. You figure out common themes. You have 3 to 4 clients, and you're like, oh, this looks repeatable. So you try to develop a product that has machine learning in it, right? So we are at that stage right now, which is very interesting. And if you want to be scaling, of course, you need to look at these tools and you need to invest. And if that means getting outside investment, then that means getting outside investment.
Yeah, just interesting for me to look different companies, how they grow their maturity. They're trying to different kind of tools and find them useful or not, and just experimenting. And usually at the beginning, they just do not really understand the problems around why do we need these tools. We had these kind of questions during the conference. People like, why do we even need these things? ML flow, can we just deliver something into production?
Yeah, it depends on where you are in your journey, right? If you haven't hit your head against the wall, I guess you don't think about it.
Yeah, I think if you don't know why to use it, just don't, right? That's what we do.
Yes.
Probably you need just to kind of come across the problem, then just fix it.
Yes, which is why retros are important, right?
Absolutely.
Technical practices and using the lessons learned. The thing that Ashley said, where lessons are sitting there for a while, is also another big problem that I see, that people write out their lessons and they're like, okay, we should probably not do that again. But then it's implementing that and making the change internally is also like very hard. Like you're talking about like, okay, we're going to go to the client and do change management. But then you really have to be very stringent about your internal change management as well, where you're really applying those lessons learned from your own stuff and trying to improve always, right? Bring in technical practices, like pair programming, all the cool tools and all that. So.
And I have so many questions, but this is kind of 5 minutes later. Okay, last question from me. One of the things I'm just curious about is we had to have just one kind of a role, which is data scientist. Just more people coming and more specialties coming into the market. I mean, more data engineers, like maybe ML ops, and the people start specializing along your lean kind of workflow, right? So it's just different people do different parts of that workflow. And sometimes it's for different people that are coming from Agile, it seems like it's just can slow down the delivery because you have different kind of people during different, and they have to collaborate, communicate, and just hand off probably. The voice that you've been missing there, hand off, as far as I remember.
Yes.
This kind of handing off the task. And what's your opinion? What do you think? Do we need to have just one data science that can do everything, just get senior guy that can do everything, or we just have to have this kind of a small roles along the way? We have to kind of...
Yeah, I think at a certain point the reality hits that there's not that many full stack data scientist unicorns out there. They're very expensive. And if you train yours, unfortunate reality is they'll probably get bought out later. So I would say there is no way around specialization in teams. You really want to have your team as cross-functional as possible. But it's your job as either a Scrum Master or product owner, whatever your experience is, to make sure everybody is aligned and the handoffs are minimized. Now, some things you can't break reality, like data analysis sometimes just takes time, right? Engineering takes time, but you really want, again, the slicing pieces, and this is where you're like, the way you think about the plan and the way you think about the delivery and how you slice it is very important, right? Because I don't see a way to have 4 full stack data scientists deployed to one client in a very like cost-effective manner.
Okay.
And it's very hard to find those guys and keep.
Yeah, because I come across with this kind of opinion. I absolutely agree with you actually, but there are several kind of pretty smart guys in the field that think that they just hire top-notch guys, from that can do everything and just insist on not having like specialization, which is not good thing to do.
Well, it's good for them, but for your company, usually, I mean, it's good. It's just very hard to keep them on. It's very hard to, the reality of the market. For example, here in Toronto, it's, you get a full stack data scientist and, you get picked up by Google or Facebook or whatever.
Oh, I see.
Or another startup that just got $100 million and they just need to just throw cash at people. But yeah, so again, I think the field is maturing, and I see a lot of books coming out. Like Andrei Burkov's book, ML Engineering, is very good, the latest one. Field is maturing, and people are realizing how to standardize a lot of this stuff and figure out processes, and will rely less on these full stack unicorns. And I think it will just keep going there. It's just really about figuring out your process in accordance, in addition to all the technical knowledge and practices. And you just have to treat them as equally important, most likely.
Yeah.
If you want it to succeed, yes.
Well, actually, it's just hard to kind of argue because I agree 100%. Well, the last question is about the role of product owner, which has a lot of, again, discussions. What does it mean to be a product owner? Or product manager, whatever you call this kind of guy. Who's product manager for you? Can you define this kind of guy? What is important for product manager in AI? I would say, what's the difference between AI product manager and just, your basic, ordinary, normal product manager?
Yeah. The difference is the domain. So the machine learning is very peculiar, very specific in the way that it's set up. And this is why in my talk I said, always remember it's iterative. Like I've had this whole discussion with data scientists always, like the projects are like a tree search and you have to go. So you have to be mindful. Ideally, you want a product manager that's at least, played around with Jupyter notebooks and have deployed his own models, but of course you can't always get that. I think the basics of product management have to be strong with the person, as in he always has to have the mentality of ship, get everybody organized, get alignment, figure out.
So for example,
AI, he needs to know the AI specifics. He needs to know that you can't just push. This
is my next question. This is just not, it was just a beginning of the question, but the actual question, just imagine I'm a product manager coming from like a normal product management. I was assigned to AI kind of product or whatever, just AI, big data department. I had been assigned to big data department of some telecom company. And I'm trying to figure out how to be a good AI product manager. What would you recommend me to kind of start my journey to AI? What should I kind of understand for to be a good AI product manager?
Okay. Well, aside from the fact that you need to understand your users and all of that.
Yeah,
stuff,
probably I'm product manager, so probably I know that.
So So talk to the data scientists. That if you want fast, you just tell them, hey guys, like, to be honest, I'm new to this. Can you explain this in very basic terms? And you just pick up in terms of, it's like learning anything else, right? Pick up on stats. Like if you come with a good product management background, you probably know A/B testing and all that, and you probably know the stats basics, right? But then
you need economics,
how to use
kind of
yes. But then exactly how statistical learning, because this is machine learning is statistical learning, right? Back in the day. So get to really get the basics of the statistical learning nailed down, and the machine learning. So some of the good courses are like Andrew Ng's, like structuring machine learning projects, right? Or there's a lot of resources out there that I can share later. But yeah, it's really find the channel of communication with the data scientists and pick up on some foundational concepts of. And just take Andrei Burkov's book, 100-page machine learning book. Just go through it.
Can you just write it down just for me?
Sure.
Andrei Burkov. What's the name of the book?
100-page machine learning, I think. Yeah, I can.
Okay, I will find it. Thank you very much. I think that was the last question. Okay, we have to stop somewhere. Thank you very much again for your talk. And hope we can see you soon. We're gonna have just the beginning of what we do here. I hope you kind of see that we just starting. It was like 30 people in here in Zoom, and probably I don't know how many people on YouTube watching us there. But this is the beginning. I hope you can just bring more like knowledge and insights for us. And if you guys, by the way, want to do some kind of a talk presentation, just email me or find me somewhere.
Okay.
Where we can do
Thank
it.
You. Thank you. I think this is a very good initiative. Thank you. Thank you very much. I think this is very good. This is something really, really exciting. Merging, being in data science. It's very good.
Okay, thank you very much, everybody. Thank you for staying late. We're just 40 minutes late. So, see you. Bye.
Thank you. Bye.
Thank you. Bye.